Alright, we'll see how this goes, and I apologize in advance for my voice, but I am fighting a little bit of a cold still. So we're going to continue looking at a number of different shapes, some shapes that you're pretty familiar with, but maybe some formulas that you haven't seen before. So we're looking at the areas of trapezoids, rhombi, and kites. So we're going to start with trapezoids. Remember, in a trapezoid, you got two bases. Those are the sides that are parallel to each other. And then you have the height. The height is defined as the perpendicular distance between the two bases. So the formula to find the area of this is to take our bases and add them together and divide by 2, or the average of the bases, and then we're going to multiply that by the height. So here's a very, very easy example of a trapezoid problem. So in this case, one of the legs is actually the height since it's perpendicular. So that's 6 inches, and my two bases are 7 and 11 inches. So according to my area formula, I'm going to take and add 7 and 11 and divide by 2, and then I'm going to multiply that by 6. So 7 plus 11 is 18, divided by 2 is 9, and 9 times 6 is 54 inches squared. Make sure you label that correctly. Alright? So, I've shown you an easy version. Here's what I'd like you to do now. I'm going to show you this problem a little more difficult. I'd like you to think through how you would do this. Once you see the problem written out, push pause and try to work on it before you have me show you how to do it. So this is an isosceles trapezoid, and I want you to think what happens as a result of that. Alright, so hopefully you thought about doing something like this. If I draw those heights in, only in an isosceles trapezoid will it create a rectangle in the middle and two congruent right triangles at the end, each, in this case, having a base of 5. So I can use Pythagorean theorem to do 5 squared plus my height squared equals 12 squared. So 12 squared is 144, minus the 25 is 119, and the square root of 119 is like 10.9. Now that I have my height, I can go ahead and use my area formula, take my two bases and average them. So the average of 10 and 20 is 15, and then multiply that by the height, which is 10.9. And when I multiply all that out, I get 163.6 centimeters squared. Let's try one more trapezoid problem here. And again, once you see it, please go ahead and push pause on this and try it first. In this case, we're going to use the area to actually find one of the missing lengths. So I'm giving you the height in this problem. So the height is going to be 8 millimeters. I'm giving you one of the bases is 9, and I'm looking for the other one. The area is 100 millimeters squared. Go ahead and push pause at this point. So hopefully when you plug everything in, it looked like this. 100 equals 9 plus x divided by 2 times 8. I'll help you with your algebra here. First thing you're going to do is undo the 8 by dividing it to the other side. Next, you're going to undo the 2 by multiplying it to the other side. And then finally, you're going to undo the 9 by subtracting it to the other side to get your other base of 16 millimeters. Algebra is a little bit trickier there. Let's move on right now to our second shape for today, which are rhombi. Remember, a rhombus is defined as a quadrilateral with 4 congruent sides. What I think is even more important, though, is that you remember the characteristics of the diagonals in a rhombus. I hope that you remember that they are perpendicular to each other, forming right triangles. I hope you remember that they are angle bisectors. And I also hope that you remember that they bisect each other. So a lot of information if you remember those things about the diagonals. So our formula is d times d over 2. What is d? Well, d is each of the diagonals. So I'm going to take my two diagonals and multiply them together and then divide it by 2. So here's a very easy example of a rhombus. We would love to have a problem like this all the time. I would not get my hopes up for that if I was you. So again, remember we said that the diagonals bisect each other. So I know that if that one piece there is 7, then the other piece is also going to be 7. And I know that if the one piece is 5, then the other piece is going to be 5. So my diagonals are 14 and 10. Multiplied together is 140. Divided by 2 is 70 yards squared. Okay? Again, I've done an easy version of this problem. Here's a little trickier one for you to work on now. In this case, I'm only going to give you the length on the outside of the rhombus. We'll call that length 9. And I'm going to give you the angle down in the corner is 100 degrees. Go ahead and press pause right now and work on this. Alright, so hopefully you drew your diagonals in. And again, remembering those characteristics about the diagonals, when you do that, you create right triangles. Let's focus on the right triangle down here at the bottom. Let's pull that out and let's see what we know about it. Again, we know it's a right triangle. We know that since it's an angle bisector, that angle is 50, and we know the hypotenuse is 9. We need to find those other two lengths of the triangle because those are half of the diagonals. I'm going to do a law of sines problem for this. Sine of 50 over y equals sine of 90 over 9. And when I solve that, I get y equals 6.9. Now I can use Pythagorean theorem, or I could use another SOHCAHTOA kind of problem and do 6.9 squared plus x squared equals 9 squared. And when I solve that for x, I'm going to get about 5.8. Now remember, that's half of each diagonal. So I'm going to take the 5.8 and I'm going to multiply that by 2 to get the entire diagonal that is going from the top left to the bottom right. So that's going to be 11.6. And then I'm going to take the 6.9 and double that. And so 13.8 is going to be the length of my diagonal that's going from the bottom left to the top right. So those are the numbers I'm going to put into my area formula. The 11.6 and the 13.8. I multiply them together and divide by 2. And my final answer is going to be 79.8 centimeters squared. Alright, let's move on to kites and we'll wrap this up. Remember that kites are quadrilaterals with no parallel sides, but with two pair of adjacent congruent sides. Again, the diagonals have some interesting characteristics. They're perpendicular to each other. One is also an angle bisector, and one bisects the other diagonal. The area formula for kites is exactly the same as the area formula for a rhombus. We multiply our two diagonals together and divide by 2. Here's a very easy version. I don't know why I'm even showing you these easy ones, because you're never going to see this on a quiz or a test. Multiply those two together. So 10 times 25 is 250. And divide that by 2. And your area is 125 square feet. Let me give you the opportunity now to do a problem that probably is a little bit more quiz-worthy. I'll tell you when to pause this video because I need to give you a little bit extra information here than what I originally write on here. That angle is 20 degrees. That part of the diagonal is 7. We're going to find the area. Again, don't pause this yet. I've got one more piece of information that I want you to jot down. Give me a second. Let's go ahead and give you this the top portion of this diagonal. Let's say that this is 8 centimeters. Now you can go ahead and push pause if you like and try to find the area. Alright, so hopefully you follow my cue here to do a SOHCAHTOA problem, and you found the bottom piece of that diagonal to be 19.2. We're going to add the 8 to that to give us 27.2 for one diagonal. We know that the other diagonal is getting bisected, so 7 times 2, or 7 plus 7, is 14. Now I can take those two diagonals and multiply them together. So 27.2 times 14. That gives me 381.3 divided by 2 is about 190.6 centimeters squared. Alright, you need to get some practice with this. Please do these homework problems. We'll discuss these tomorrow in class. On pages 733 and 734, I'd like you to do problems 3 through 32. Alright, we'll see you tomorrow.